Hey everybody, this is Mr. Munson, and we are doing unit G.4, which is triangle inequalities, triangle relationships, things like that. So this is concept number one. And so if you look at your student learning map for concept number one, we're dealing with relationships between sides and angles. Basically, what we're going to be looking at is if we knew the angles inside of a triangle, then we should be able to tell by those angles which side is the largest side, which side is the smallest side, and which one is the medium side. In a problem like this, I would have to go and find out what that angle is first. I could use the triangle sum theorem to do that. But anyway, we'll learn that and get a little bit more in depth on that when we get there. All right, let's go ahead and get started. Just a real quick reminder what an inequality is. It's just basically a less than or greater than sign, right? An equality is an equal sign. We solve inequalities the same way we do regular equalities. We get the x's on one side and the numbers on the other. I like to make my x's positive, so I'm going to move these negatives off that side and put them on the other side, and I end up with 4, and this is 8x plus 10. And then I would subtract 10 from both sides. You can see that inequality gets used the same way. It doesn't change unless I divide by a negative number or I multiply through by a negative number. So since I'm not doing that, that sign doesn't change its direction. All right, there we go. So this statement basically says the x's I'm looking for are smaller than negative 3/4. Okay, I hope that you know how to solve equalities already. Let's move on. All right, let's take a look at this theorem real quick. This theorem basically says if two sides of a triangle are not congruent, meaning that there's three sides that are all different sides, then the largest angle lies opposite the larger side. The larger angle lies opposite the larger side. So take a look. Hopefully you can see that 5 is the largest side here. So the angle that's opposite that 5 is angle B. So let's say I wanted to order these largest side or largest angle to smallest angle. Okay, so I would say angle B is the largest angle because it's across from the largest side. I'm using this theorem they just gave me. Let's go to the next one. All right, so again, the side 4 is the next largest side. So across from that is angle A. And then finally, we have the smallest side, which is across from angle C. All right, now we went largest to smallest. Now I'm going to use inequalities to state largest to smallest. So since we're talking about the actual measure when we're talking inequalities, we're talking about a number, I'm going to write an M in front of it and say this is the largest side. So by doing so, I'm going to have the arrow point the other direction. This is the largest angle, okay? Since this is the largest angle, everything to the right is going to be smaller, so I have it pointing off in that direction. Well, the next up would be the angle A, and then the next up would be angle C. Just look at that notation. When I'm using the comma, I'm using the name of the angle, and when I'm talking inequality, I use the measure of the angle. Let's go on. All right, let me have you do this one, both with the inequality and with the list format with the commas. Use correct notation, and I want you to list the angles smallest to largest. Go ahead and put me on pause and test your ability to do this. All right, so hopefully, as you can see, 8 would be the smallest side, so that would be angle A is the smallest angle. Next up would be 10, which is angle C. So we'd list that one next, okay? And then finally we have angle B, or side B, side 20 that has an angle of B as the next smallest side. Okay, so that's the order of the angles, A, C, and B. Now let's write it as an inequality. Again, I'm just going to put the M in front of it, which represents in um, the mindset here that we're talking about the measure, the actual angle measure. Now, since we're going smallest to largest, this is where you might have made a mistake, okay? The inequality changes direction. We need A to be on the smaller side of the inequality, okay? So go back and erase it if you simply just put the larger or the greater than sign there. And so since we're doing smallest to largest, logically the arrow has to point the other direction. All right, very good. Well, guess what? We find out that the converse of this theorem is true as well. If we know the angles and the order of the angles, then we know the order of the sides. Across from the largest angle is the largest side. Okay, so what I want you to do is draw this picture, of course. I want you to put me on pause and see if you can order the sides. Now, let me just write the side names up here for reference sake. We have these three sides. So now what I want you to do is in list format, write down these three sides in the order from largest to smallest. Go ahead and put me on pause and see if you can do that on your own. All right, so we're going largest to smallest, so we go to the largest angle first. If you look at the largest angle, which is 120, it points to AC as being the largest side. Okay? Then comes the 35-degree angle, which would point to BC being the next largest side. And then that, of course, by logic, leaves us the last side, AB, as being the smallest side. Okay, so let's write that as an inequality. Now, when we're writing the side lengths of things, we don't put an M in front of it. We drop the bar on it, okay? So we write it like that. That represents the number, how whatever, 7 feet, 10 feet, whatever it is, when we write AC like that. Now we're looking at the largest side, so the larger part of the inequality is going to be on the side of the larger side. So then we write it in order like that. Okay? All right, pause and take a look at that notation. Make sure you understand how to write the notation. When we're writing the name of the segment, we write the bar above it, and we put commas in between it to give the idea it's a list. And when we're doing an inequality, we drop the bar because we're actually talking about the measure, the actual number, and numbers are greater than and less than and also equal to each other. All right, let's move on to the next idea. All right, have yourself another go at this. We have 89, 47.5, and 43.5, and we want to order this largest to smallest. Now, go ahead and do that and write it in both forms, list form and using the inequality symbol. Put me on pause and come back and check your work. Okay, so the largest angle is going to be that 89. And I'm going to encourage you again to circle the angle, draw an arrow to the side to help you, kind of visually see what's going on. So it looks like BC is the largest side. Then comes the 47.5, which is AB, the next side. Then we have the final side, just through logic, we have a third side, right? It has to be AC, is the smallest. Whoops. That's in list format. Now let's do it as an inequality. And this is where our thinking has to make sure that our sign is pointing in the correct direction. Okay? It's pointing to the right, indicating that the numbers are getting smaller. The largest number is starting on the left-hand side, and the smaller numbers are descending to the right. All right, let's do another problem. Have at it. Come back and check your work. Read the directions, figure out what you're supposed to do, and do it in both ways, list format and inequality format. Have fun. All right, and there you have it. Let's go on to another. All right, let's take a look at this one. So I need you to order the angles for triangle ABC, where AB is 8, BC is 5, and CA is 7. Now, to make this one easier for you, um, I would, again, want you to use your problem-solving skills that we've taught in class about, hey, you know what? If information is given and there's no picture, draw it, okay? So let's start you off by drawing a picture and putting that information in it, and then I want you to order the angles smallest to largest, okay? Come back and check your work as soon as you're done. Okay, that should be your order, right? The smallest side is the 5, and so angle A is the smallest angle. Across from the 7, which is the next side of length, is measure or angle B, and so the measure of angle B is the next largest, and then finally we end up with the largest of the angles, and that's going to be angle C. Okay, make sure you understand how to do an inequality statement and then a list statement. Okay, now this is not part of this unit, this concept, but I want to make sure that you have this idea. We've talked about this idea before. We have this angle on the outside here called the exterior angle theorem, or exterior angle. It's basically created by, again, extending one of the sides to create that angle, okay? Now, if I knew what this angle was, then I could write an equation, you know, whatever this is plus this has to equal 180. That's the linear pair theorem or postulate, linear pair postulate. But I don't know that, and since I don't know what these two, I know what that angle is, but I don't know what this one is, I can't write the triangle sum theorem to find out what that is. So there's this relationship I want to remind you about. This exterior angle has a relationship actually with these two angles that are the furthest away. They're both interior angles, but they're not the one next door, but the two furthest away. There's a relationship that I want you to remember, and that relationship is the equation. The exterior angle is equal to the sum of those two remotes. It's just me, basically, I'm going to add up those two other angles and set them equal to that exterior angle. It's that simple. So I just plug the information in. X plus 3 equals 40, and then the other angle, 2x plus 40. And I'm assuming at this point that you could solve that and find out what x is. If I wanted to know what that angle was, I'd plug it in, right? I need to remember to plug in. Suppose I asked you, what is this angle? I'd still write this same equation, find my x, and then I would plug it in here. It doesn't matter. And if I wanted to know what this angle is, then I'd plug it in here, find out what this angle is, and then I'd say, okay, those two have to add together to give me 180. So I'd add whatever this is, you know, 120 degrees or whatever it would be. I'd say, oh, well, 120 plus what gives me 180. And then I'd be able to find that missing angle. So I have enough information to find everything I need to know about this triangle given this relationship. Okay, go ahead and draw your line, write summary. Give yourself a few minutes to write down a summary, and let's move on to our do it problems. All right, here's your do it problems. I'll scroll up. There's a couple more that are not being able to be seen. I'll scroll up. Obviously, there's no drawings. I'm going to want you to draw the drawings. Don't forget to include the original information. All that information should be written down on your paper, your work neatly underneath it, and don't forget to circle your answers, right? Circle answers, okay? Please don't complain to me when I don't give you credit and you don't have your answers circled. I'm not going to go looking for answers anymore. All right, let's scroll through this and see what you got. Oh, look at that. We have an exterior angle theorem problem right there. Let me get everything out of your way so you can see it. All right. Okay, very good. We'll see you next time.